Hello students, this is the third lecture in the NSEJS series. So in the previous lecture we have already seen the concept of ions. In this particular lecture we are going to see how the ions actually form. So the formation of ions is going to be the topic for this particular lecture. Fine. So we already are aware that ion can be positively charged and we call them cation, and there can be negatively charged an ion, and we already know from the previous lecture that in case of ions the number of protons is not equal to the number of electrons. We also know that you cannot change the number of protons for any particular atom in the normal reactions. You cannot change the number of protons, you cannot change the number of neutrons. All that you can change will be the number of electrons, right? So basically atomic number and the atomic mass will remain same if any atom is undergoing a chemical reaction. Fine. Let's try to understand how do the cations form. We'll see one by one. So first we'll see the formation of ions. Formation of cation. How do the positive ions form? So we'll start with an example. Let's assume that we have sodium over here. Atomic number is 11, right? Let's assume that it loses sodium atom over here. It loses one electron. Minus 1, it denotes that one electron is lost. Correct? Now, let's do the calculations first for this particular case, when it has not lost the electron. Correct? In this particular case, we already know that atomic number is 11. So do we know that the number of protons is 11? Right. So because of 11 protons, do we have plus 11 positive charge over the sodium? Fine. Since this sodium atom is neutral, we don't see any positive or negative sign over the sodium. So do we have the same number of electrons? So number of electrons over here is same as the number of protons, right? Because in neutral atom, the number of protons and electrons are same. Now, because of 11 electron, the total number of negative charges will be minus 11. And if you calculate the total charge over the sodium atom, total charge, if you calculate, so you see, if you do the simple mathematics over here, you get 0. That is why sodium over there is neutral, because it is showing the net charge of 0. Fine. What happens to the sodium if it loses one electron? So let's do the calculations very quickly. The atomic number remains same, we know that, right? We cannot interfere with the number of protons. Fine. So the number of protons remains same. We still have 11 protons, and because of 11 protons, the total positive charge should be plus 11, right? What happened to the number of electrons? Initially, over here, you see we had 11 electrons and it lost 1 electron. So do we have 11 minus 1 equals to 10 electrons now? We are left with just 10 electrons now. So negative charge because of 10 electrons will be minus 10. Let's calculate the total charge. TC over here is the total charge. We get plus 1, right? So this charge over here will reflect over the atom, Na plus or Na plus 1. Atomic number remains same, atomic mass remains same. Correct? The atomic number and atomic mass remains same. So what happened here? The sodium atom formed a cation, right? Let's see the next example. Let's take magnesium, atomic number 12 and atomic mass 25. Okay. The atomic number is given to us, it's 12. So the number of protons is 12, and so the positive charge will be plus 12. Since it's neutral, we don't see any positive or negative sign over the magnesium, so it's neutral. That is why we have the same number of electrons, and because of 12 electrons, the total number of negative charge will be minus 12. If we calculate the total charge, we get 0, right? So magnesium in this case is neutral. Fine. Let's assume it loses 2 electrons. Now what happens after the loss of 2 electrons? Since electrons is lost, and we know that the atomic number will remain same, so the number of protons remains same, and because of 12 protons, again the positive charge that we have is plus 12. But we don't have the same number of electrons anymore. Out of 12 electrons, it lost 2 electrons. We are left with 10 electrons now, right? Because of 10 electrons, the total negative charge will be minus 10. And if you calculate the total charge, you get plus 2. This total charge, the net charge, will be reflected over the atom on the right hand side here. Atomic number remains same, atomic mass remains same, right? So can we say that magnesium formed a cation over here, right? Let's see one. Now let's see the general example. Let's assume that there is any atom X, fine, atomic number G. It will have some atomic mass. Atomic mass is not involved in this, so let's ignore it for now. Okay, since atomic number is G, so number of protons will be G, equal to the atomic number. And so the total number of positive charge will be plus G. Fine. Number of electrons will also be the same, G only, because it's a neutral atom. So the total negative charge will be minus G. And if you calculate the total charge, we get 0. X is neutral, right? Now, let's assume that this atom X lost certain number of electrons. Assume it lost n number of electrons. Fine. The atomic number does not change. We know that it remains same. So number of protons remains same, and so did the positive charge. So the positive charge is still plus G, right? But the number of electrons has reduced. It has become the initial number of electrons G minus the number of electrons lost n, right? So the negative charge will be equal to the number of electrons left, and we have G minus n number of electrons left. So negative charge will be G minus n, right? Now do the calculation, calculate the total charge. You will find plus n charge is left. This net charge will be reflected over X as this. Atomic number remains same and atomic mass also remains same. Let's observe something over here in these three cases, these three examples that we have taken. So let's take a look. Okay, do we see that sodium, when lost electron, let's focus on the loss only for now. When lost electron, it developed positive charge, right? Second case, when magnesium also lost electron, it developed positive charge. In third case also, we see when X lost electron, it develops positive charge. So from here, can we draw a conclusion that the loss of electrons leads to formation of cation, right? It's quite understandable to you also. The logic is quite understandable. This is the atom, right? This hand had some number of protons, suppose X number of protons, and he has some Y number of electrons, correct? Okay, if this person is to be neutral, the number of electrons should also be same as the number of electrons. We know that that is the case of neutrality for any atom. Fine. Just assume if this person loses the electron, so does this also mean that the number of positive charge is more than the number of negative charge, right? Because initially you have the same number of protons and electrons, and since you are losing your negative charges or electrons, so basically you will have extra number of protons. Because of that only the positive charge develops. So the loss of electrons will always lead to the formation of cation from the neutral atom. We'll keep in mind, from neutral atom, right? So if you remove the electron from the neutral atom, it will always lead to the formation of cation, right? Now let's do the second observation now. Sodium, when lost one electron, it developed plus one charge. When it lost one electron, it developed plus one charge. Magnesium, when lost two electron, it developed plus two charge. Can you just establish a connection between the number of electrons lost and the charge developed? Yes, we are able to. When sodium lost one electron, the charge developed was 1 plus 1. When magnesium lost two electron, the charge developed is plus 2. And when X lost n number of electrons, the same magnitude of charge was developed over here. So can we just say that the charge developed is equal to the number of electrons lost. We'll keep that in mind. So how do the cations form? It is formed by the loss of electrons. First thing, how much charge is developed? The charge developed is equal to the number of electrons lost. So let's see the few examples quickly. So if, for example, aluminium, if loses 3 electrons, it will become Al plus 3. Plus charge because electrons are lost. 3 charge 3 because 3 electrons are lost. Right? Lithium, if it loses 1 electron, it becomes Li plus 1. Positive charge because electrons are lost. 1 charge, magnitude of charge is 1 because 1 electron is lost. Correct? Chromium, if it loses 3 electrons, it becomes Cr plus 3. Plus charge because electrons are lost. Magnitude 3 because 3 electrons are lost, etc. So this is going to be the case in any particular atom. So if there is any atom Y, okay, if it loses m number of electrons, it should become Y plus m. Fine. So this was about how do the cations form. Now we'll see the formation of the negative ions. We already know the formation of the positive ions now. Now we'll see the formation of the negative ions or anions. Right. So again we'll start with an example. Assume that we have oxygen. Atomic number is 8, atomic mass is 16. Suppose oxygen gains 2 electrons. Suppose that oxygen over here gains 2 electrons. So let's analyze the case before the gain or loss of electron, or in this case gain of the electron. So do we know that atomic number is 8, so number of protons is 8, and so the positive charge because of 8 protons will be plus 8. Now one more thing we see, that there is no plus minus sign over the oxygen atom, so it's neutral. So the number of electrons is same as the number of protons, and the negative charge developed will be minus 8. Right. If we calculate the total charge, we get 0. Oxygen is neutral in this case. After the gain of 2 electrons, what happens? The atomic number does not change, we know that. If the atomic number does not change, the protons does not change, and so the positive charge because of 8 protons will remain same. But did the number of electrons changed? Yes, it changed. Now you have 2 extra electrons because oxygen gained 2 more electrons, right? So basically you have 2 extra electrons now. Total number of electrons is 10. Because of 10 electrons, the negative charge developed will be minus 10. And if you calculate the total charge, you get minus 2. So this charge over here, this minus 2, that is the net charge that oxygen atom is going to show. Will it be O minus 2? And is there any change in the atomic number and atomic mass? No, there is no change in the atomic number and atomic mass. Let's take one more example. Let's take fluorine, atomic number 9, atomic mass 19. Let's assume it gains 1 electron. Correct? Now, atomic number is 9, so the number of protons is 9, and because of 9 protons, the positive charge is plus 9. Fine. What about the number of electrons? Are they same? Yes, they are same because again, fluorine over here is neutral. So negative charge because of 9 electrons will be minus 9, and the total charge developed will be 0. fluorine is neutral. Let's see what happens when it gains one electron. Fine. Now, atomic number does not change once again, right? So number of protons does not change, and so do the positive charge. It remains same. But now you have one extra electron. Because fluorine gained one electron, total number of electrons that you have now is 10. So the negative charge developed will be minus 10, and the total charge will be minus 1. So this net charge minus 1 will be shown over here. You can simply write F minus 1 or simply F minus also. Let's take the general case. Let's assume that there is any atom X, atomic number G, atomic mass A, and assume that it gained n number of electrons. Okay. So number of protons equals to G, atomic number. So positive charge developed is equal to the number of protons. Since X is neutral, so we have the same number of electrons. And so the negative charge developed because of the G number of electrons will be minus G, and the total charge will be 0. Right. Let's see what happens if it gains n number of electrons. So we know that the atomic number does not change, so number of protons will remain same. So do the positive charge plus G. But number of electrons has increased by n because it gained n number of electrons. So the negative charge developed because of these many electrons will be minus of G plus n. If you calculate the total charge, you get minus n. Now this total charge is the net charge that X is going to show over here. Now it's time to draw some conclusion, important conclusion. So let's see what is that. We see that oxygen, when gained electron, it developed negative charge. In the next case, fluorine, when gained electron, developed negative charge. X, when gained electron, developed negative charge. So is this clear to us that the gain of electrons leads to the formation of negative ion or simply anion? Right? Again, you can understand it through this. This person initially had same number of protons and same number of electrons, right? So currently the number of protons and electrons are same, but just assume that there is some person over here who is giving suppose 2 electrons to this person. So if this person gives 2 electrons to this person, will this person have 2 extra electrons? Yes or no? That person will have 2 extra electrons, and because of those 2 extra electrons, this person will carry minus 2 charge now. In other words, if this person gives n number of electrons to this person, in that case, will this person have n extra number of electrons? This person will have n extra number of electrons, and in that case, it will show minus n charge, right? So this is quite clear to us that the gain of electrons will lead to the formation of negative ion. Why? Because initially the number of electrons and protons were same, the total charge was 0, but as it was supplied with the extra electrons, there will be some net charge because of those extra electrons. Fine. Now let's see one more. We have to draw one more conclusion. Oxygen over here gains 2 electrons, so developed the magnitude of charge is 2 minus 2. Fluorine, when gained 1 electron, it developed minus 1. X, when gained n electron, developed minus n. So can we say that magnitude of charge developed is equal to the number of electrons gained? How many electrons it has gained, that will be the magnitude of charge developed, right? Of course, if gained, negative charge. So let's quickly take some examples. So suppose that sulfur gains 2 electrons. Since it is gaining, so first thing is clear to us that it will develop negative charge. How much negative charge? Equal to the number of electrons lost, minus 2. right? If phosphorus gains 4 electrons, right? Sorry, 3 electrons, it will become -3, right? Similarly, if oxygen gains 2 electrons, it will develop O-2, it will become O-2. If there is any atom Y and if it gains m number of electrons, it will simply develop Y minus m. Fine. So we are quite clear with how do the positive ion or the negative ion form, right? So this is also clear to us that if there is a neutral atom, right? So neutral atom, this is the conclusion of what we have studied so far. So if a neutral atom loses the electron, so loss of electron will lead to the formation of cation, but if it gains the electron, it will become a anion, right? Okay, one more thing. So we can say over here that ions are formed by loss or gain of electrons from neutral atom. We'll keep this particular statement in mind. We also have understood the logic, right? Okay, so ions will be formed only when the neutral atom lose or gain the electrons, correct? Fine. One more thing. In case of cation, we saw that charge is equal to the number of electrons lost. In case of anion, we saw that the charge developed is equal to the number of electrons gained, right? So in total, if we have to summarize that for an ion, for any particular ion, can we say that the magnitude of charge will be equal to the number of electrons lost or gained? We'll keep this in mind. Whatever the charge, whether it be positive ion or the negative ion, the magnitude of charge will always be equal to the number of electrons it has gained or lost. So this was about the how do the ions form. In next class, we are going to in the next lecture we are going to deal with even more interesting topic, that why certain atom is going to lose the certain number of electrons only. Why, for example, aluminium always forms Al plus 3 only, why it cannot form Al plus 2, or why it cannot form Al minus 2 or minus 3, why it always forms Al plus 3 only whenever it forms the ion, why sodium always forms Na plus 1 only, why fluorine always forms F minus 1 only. We will be answering these questions in the next